So hi everyone, welcome to my YouTube channel. Myself Sanjeev Reddy. I am from Sri Venkateswara College of Engineering. Today we are going to discuss about superconductivity. Definition of superconductivity. Superconductivity is a phenomenon occurring in certain materials generally at very low temperature, characterized by exactly zero electrical resistance and the exclusion of the interior magnetic field. In a simple words, for some materials, the resistivity vanishes at some low temperature. They become superconducting. Such materials are called as superconductors. Discovery. Superconductivity was discovered on 1911 by Haig Honors, who was studying the resistance of solid mercury at cryogenic temperatures using the recently discovered liquid helium as a refrigerant. At the temperature of 4.2 K, he observed that the resistance suddenly disappeared. In subsequent decades, superconductivity was found in several other materials. Critical temperature. The temperature at which electrical resistance is zero is called the critical temperature. The cooling of the material can be achieved using liquid nitrogen or liquid helium for even more lower temperature. The Meissner effect. In 1920, Meissner discovered not only did superconductor exhibit zero resistance but also spontaneous expel all magnetic flux when cooled through the superconducting transition. That is, they are also perfect dimagnets. We call this the Meissner effect. The limit of external magnetic field strength at which a superconductor can exclude the field is known as the critical field strength, HC. BCS theory. The complete microscopic theory of superconductivity was finally proposed in 1957 by Bardeen, Cooper, and Schrieffer. This BCS theory explained the superconducting current as a superfluid of Cooper pairs, pairs of electrons interacting through the exchange of phonons. For this work, the authors were awarded the Nobel Prize in 1972. BCS Cooper's pair. A Cooper pair is the name given to electrons that are bound together in a certain manner, first described by Leon Cooper. In normal superconductors, the attraction is due to the electron interaction. The Cooper pair state forms the basic of the BCS theory of superconductivity. Formation of Cooper pairs. Cooper pairs are formed by an attractive force between electrons from the exchange of phonon. The energy of phonon is usually less than 0.1 electron volt. When a metal is cooled to the critical temperature, electrons in a metal form Cooper pair. Cooper pairs are electrons which exchange phonons and become bound together. Bound electrons behave like bosons. Their wave functions do not obey Pauli's exclusion rule, and thus they can all occupy the same quantum state. The BCS theory of superconductivity states that bound photons have slightly lower energy, which prevents lattice collisions and thus eliminates resistance. As long as KT is the binding energy, then a current can flow without dissipation. Josephson's effect. When two superconductors are joined by a thin insulating layer, it is easier for the electron pairs to pass from one superconductor to another without resistance. This is called the Josephson effect. This effect has applications for superfast electrical switches that can be used to make small, high-speed computers. Specific heat. A finite jump in the specific heat is observed at the critical temperature. In a superconducting phase, the electron resistance changes with the jump while the energy undergoes a continuous variation. When the substance is cooled, its specific heat typically decreases, but at the critical temperature, it increases suddenly. Superfluidity. This phenomenon was first observed in helium at temperature below 2.17 K. Helium had this temperature flow quite freely without any friction through any gaps and even small capillary tubes. Once it is set in motion, it will keep on flowing forever if there are no external forces acting upon it. Unlike all chemicals, helium does not solidify when cooled down near absolute zero. Thermal conductivity. In an ideal superconductor, there is a marked drop in the thermal conductivity when superconductivity sets in. In non-ideal superconductors, an increase in thermal conductivity on becoming superconducting has been observed in few specimens. Applications of superconducting. Some of them are magnetic leviation, magnetic field detection, power transmission, superconducting generators. Conclusion that superconductivity is one of the important discoveries in the field of modern physics. The mentioned properties predicts that the superconductivity can be classified into different types. The advantages of superconductors is their capability of carrying enormous amount of power without loss under critical temperatures. So superconductors can save a lot of energy. Thank you.